Hi Year 12, so I have decided to start producing YouTube videos because I think this will be particularly helpful for you in case you don't pick up something during class. You have the opportunity to go home and watch the YouTube video again or as many times as you like. And also at the end of the year, when you're studying for your final exam, you have the opportunity to go back and revise some of the content that we discussed earlier in the term. I also expect from now on with the YouTube videos that I do produce that you'll be watching those prior to our theory lessons, which at this stage are on the Thursday morning. So this is really important because you will need this knowledge in order to apply it during our lessons on the Thursday. So today we're discussing nutrition and performance. So I will give you a handout during our lesson, probably our Monday table tennis lesson, if you'd have a bit of a look over in case you want to read more or you're not too sure about a particular concept we'll be discussing in this YouTube video. So as you're all aware, energy comes from three different food sources. So we have our carbohydrates, our fats and our proteins. So we use these three different fuel sources when we're exercising, predominantly carbohydrates and fats. Now, going back to some of the stuff we discussed earlier in the year, our ATP-CP system requires the creatine phosphate. The anaerobic glycolytic system requires carbohydrates as its fuel source. And then we also have our aerobic system, which predominantly uses carbohydrates but can, however, use fats as well. It's also important to note that proteins can be used, but they're only used in emergency situations. So carbohydrates and fats are our preferred source of fuel. So we've also got our vitamins and minerals. Now they don't provide energy, but they are really important for chemical reactions and normal cell function. So with our nutrition strategies, we have three different strategies. So we have got our pre-event nutrition strategy, the during event nutrition strategy, and our post-event. So the major considerations when designing these particular nutritional strategies include the intensity, so if it's high intensity, low intensity, moderate intensity, the duration, and the consistency of effort. So say, for example, within maybe a football game, you have lots of opportunities for breaks, whereas you might not have that or will not have that in a high endurance event like an Ironman or a marathon. There's quite a lot of examples. So when we talk about intensity, we're using a percentage, so 100% intensity, 50% intensity. So obviously walking requires less energy than running. So different nutrients leave the stomach at different rates. So we have liquids which empty at the stomach at a rate of 1 litre per hour. And then we also have carbohydrates which take 2 hours to empty from the stomach. Okay. Then we also have proteins which take 3 hours and fats which take up to 4 to 6 hours. Now that's because the fat is actually a larger molecule and takes a lot longer to break down. So it's important to note as well that when we consume foods, blood is directed towards our digestive system in order to break down the foods. This means that we have less blood flowing towards our working muscles, which consequently means that we have less oxygen available to our working muscles. So this is really important to remember, particularly for pre-event strategies, because it's not, if we're eating a large meal before an event or before a sporting event, it means that a lot of our blood is being directed towards our digestive system rather than towards our working muscles, which is where we need it most at that time. So I'm going to talk now about the pre-event nutrition. So this consists of two phases. We've got days and weeks before the event, and it also includes the hours and minutes before the event as well. So the pre-event has two goals. The first goal is to provide the athlete with enough energy in order to do the training required for the event. And the second goal for the pre-event nutrition strategy is to enable the athlete to build up stores for the event. So this includes the muscle glycogen stores within the muscles. So usually a pre-event nutrition strategy could consist of 55 to 65% of energy from carbohydrates and about, say, 25% from fats. So these fuels in particular, as we know, are crucial for endurance type events. Because for our endurance type events, we are predominantly using our aerobic system at any one time, and the aerobic system uses the carbohydrates and fats. So we've also need to remember that proteins are important as well. Proteins are important to consume because they help us to repair our muscles and our little tears, muscle tears in our fibers, muscle fiber tears. Okay, so usually we would consume about 1 gram of protein per kilo of body mass, and this actually goes up for strength athletes, endurance athletes and adolescents. It can go up to 2 grams of protein per 1 kilogram of body mass. Now, carbohydrate loading is a term that I'm sure you're familiar with. It's often talked about in the media, and I think a couple of you talked about it in your issues analysis. So initially this was designed back in the 1960s. So it was when 1 week prior to the event, the athlete would undergo 3 to 4 days of a depletion phase. So that would include 3 to 4 days of absolute hard training and low carbohydrates. And this was then followed by 3 to 4 days of carb loading and rest. And what they found is that the glycogen stores within the muscles would increase above what they were at resting levels. Now, as research has progressed, they've actually realised that it's not necessary to in that first phase have minimal carbohydrates. Okay, so that's not necessarily recommended now. What they're actually saying is that you consume the same amount of carbohydrates for that first phase, okay, and then for the second phase, they actually say that you taper off with your exercise, so you don't do as much within 3 to 4 days prior to the event, and you consume more carbohydrates than what you normally would. So this is sufficient in producing more glycogen stores. Now we're going to be moving along to during the event. So once again, the nutrition strategy that we use during the event depends on the activity, the intensity of the activity, and the duration. Now, as carbohydrates are our dominant fuel source, we need to be replenishing our carbohydrates and our muscle glycogen stores during the event. Now, obviously, these muscle glycogen stores are going to be depleted far more within an endurance event in comparison to a AFL football event. So as a result, the endurance athlete is going to need to consume more carbohydrates. Now, the best carbohydrates to consume during events are going to be high GI carbohydrates, which we'll talk a little bit more about on Thursday. So with high GI carbohydrates, it means that the nutrients are absorbed into the bloodstream at a faster rate, and consequently the athlete is able to use those fuels quicker than what they would if they were to eat a low GI food. Now, endurance athletes need to consume greater carbohydrates, as I said previously, in order to preserve those muscle glycogen stores and in order to prevent hypoglycemia. So we'll move across now to after the event nutrition strategies. So the aim is to refuel or restore muscle glycogen and liver glycogen, and to repair and rehydrate fluid and electrolytes, which we'll speak more about towards the end of this little video. So muscle glycogen stores can take days to replenish. So ideally, it's best to start consuming foods within the first 60 minutes after post-event and up to 24 hours after the event. So within the first 60 minutes is the best time to consume foods, including those high GI foods, because they absorb into the bloodstream faster and your muscles just suck them up. And that's consequently why you often see famous athletes or lots of different athletes consuming sports drinks after their events. So rapid resynthesis of the muscle glycogen stores is best achieved by immediate intake of about 1 gram of carbohydrate per kilogram of body mass every 2 hours. So for that first 24 hours. And this includes carbohydrate-rich foods in order to replenish, once again, those muscle glycogen stores, key term. Obviously, I need to stop saying obviously, proteins also needs to be consumed after the event in order to repair the tissue, and this usually consists of about 10 to 20 grams of protein after the event. So now we're going to be moving on to hydration. So hydration is absolutely crucial. When we talk about hydration, we're talking about the fluids that we consume. So it moistens the tissues in the eyes and the mouth. It lubricates joints, protects our body and organs and tissues. It regulates temperature, carries nutrients and oxygen to the cells. So factors which affect the intake of fluid include the intensity of the exercise, so the heat produced, the size of the athlete. So a bigger athlete with a larger surface area will need to consume more fluid in comparison to a smaller athlete with a smaller surface area. The rate at which the athlete's body uses fuel, so their metabolism, and acclimatization, so getting used to the hot temperatures. So an athlete that has been acclimatized, who's used to the working in those, whose body has adapted to those warmer conditions, will require less fluid in comparison to an athlete who has not yet been acclimatized. So when we're talking about the fluid lost within our body, we're looking at 1 kilo of water equals 1 kilo of body weight. So it helps us to decide how much fluid has actually been lost through performance. Now, if this is greater than 6%, the athlete can experience heat exhaustion, heat stroke, comas, and death. Now, even amounts, if an athlete lost 1% of body weight through sweat, that also has a significant impact on their performance. So it means that their heart beats 5 to 8 times faster. The cardiac output, so the amount of blood that leaves the heart decreases, which consequently means that we have less oxygen going to the working muscles. The core temperature increases, blood volume decreases. Once again, the O2 to the muscles decreases, and stroke volume decreases as well. So absolutely can have a huge impact on performance. In terms of recommended fluid intake rates, it's usually 500 to 1,000 mils of water before the event, 600 to 1,000 mils per hours of water of sport drink during during the event, and it's also important to consume fluids after the event as well. So once again, that can also include sports drinks, which can replenish those electrolytes as well. So when we sweat, we're obviously losing fluids. Now, if we lose fluids to the amount of, say, 800 mils, it's extremely difficult to replace. So that's why it's important for us to replenish those fluids prior to getting to that point. And this also includes replenishing those electrolytes as well, because we do lose electrolytes through sweating. And we need electrolytes to help absorb the water into our body. So these electrolytes include sodium, potassium, and chloride, and they're often found in those sports drinks. An athlete that were to lose electrolytes, a significant amount of electrolytes, may often experience fatigue, problems with concentration, etc. Okay, that's all. Thank you.